equal. Okay. We have another concept that we have discussed. This is something that is very simple because we have discussed all our properties related to the transversal. It says if two straight lines are intersected by a transversal, whatever is written, do not focus on the theory, focus on the imagination. Imagine the figure that we just drew. He says there are two straight lines, they are intersected by a transversal. Let me put it down again. Two parallel lines intersected by a transversal such that there is a pair of corresponding angles which are equal. So it can be this angle and this angle which are equal. It can be this angle and this angle which are equal. Then he say, now guys, he's talking about a reverse movement. We know that if there are two parallel lines and there's a transversal, corresponding angles are equal. He's telling us that if there are two parallel lines and there are corresponding angles, if there is a transversal and there are corresponding angles, that means the two parallel lines, A, B and C, D or whatever you want to name them, become parallel to each other. Is it very clear? Instead of going from A to B, what we just studied, he's trying to move from B to A. Very clear? Jaldi, yes or no?
Yes, sir.
Okay. Now, Priscilla, explain point number 2 on the screen. If two straight lines are intersected by transversal such that a pair of alternate angles are equal, then the two lines are parallel. Explain it to the class. Priscilla?
Yes, sir.
Yeah. Can you explain point number 2 to the class?
Sir, that they says that.
In your own words.
Sir, it's proving how it's telling us how to prove the lines are parallel.
Correct. And what pair is he talking about? Alternate angles. So alternate matlab, is he talking about alternate interior or alternate exterior, or is he talking about any of them?
Any of them, sir.
Brilliant. So what is he saying? He's saying that if
it can also be both of them, right?
yeah, it can be either of them or it can be both of them. Look, if I have angle 3 and I say I have angle 8 and I say both of them,
kind of same only, like the properties are same only.
correct. But it's just about which part we are talking about, whether we're talking about the area between the two parallel lines or the one beyond the two parallel lines. That is the difference between interior and exterior, right?
Yes, sir.
So if I say that 3 and 8, angle 3 and angle 8 are equal, what can you tell me? You can tell me that AB and CD is a parallel line which is being cut by a transversal.
Yes, sir.
Now, the last of the third point says that if we have another angle 3 and he says that given the condition that angle 2 and angle 3 are supplementary, that is they are added to 180 degrees, can I still say that AB and CD are again parallel? Going
Yes,
in a
sir.
reverse shot. This is something that we just understood on the previous slide, right?
Yes, sir. So can you repeat just now what you said, like in the last sentence?
Okay. Can you see angle 2 and angle 3?
Yes, sir.
What is the corresponding angle of angle 2? Which angle corresponds to angle 2? Which angle is equal to angle 2?
Angle 3.
No. How are angle 2 and angle 3 equal? Angle 2.
So the 3 above, beside 1.
Correct. So angle 2 and angle 1 are corresponding to each other. Angle 1 equal to angle 2 because they are corresponding. The third point says that angle 2 and angle 3 add up to 180 degrees. That is the last property that we discussed on the previous slide.
Yes, sir.
How are angle 2 and angle 3 adding up to 180? Because angle 2 and angle 1 are corresponding. That means angle 1 and angle 2 are the same. 2 and 3 are on a straight line. The angle on a straight line is 180 degrees. That is the reason 2 plus 3 is giving us 180 degrees. Are we clear?
Yes, sir.
No doubts on the slide? Bhavya, the theory is given. This is something that is given to move from B to A. What we understood is all that was important was on the previous slides, all the properties that we discussed. Are you clear with the properties and how it came out?
Yes, sir.
Okay. To understand this, let's first do this. Okay. So let's just go through this. It says basic axiom of parallel lines, Euclidean postulate. So first let's look at point number 2. He says that if two lines are parallel to the same line, then the lines are parallel to each other. What is he trying to say? If I have to imagine it, there is one line, there is another line. I have AB and I have CD. He is saying if these two lines are parallel to each other, how do we write parallel? AB parallel to CD. This is how we denote it. And he says if two lines are parallel to the same line, for example, I get another line in between. I'm drawing a dotted line, okay? It's a line. If two lines are parallel to the same line, now, do all three become parallel to each other, guys? For example, if I name it EF.
Yes, sir.
That is what he's trying to say. Whatever is being put in terms of theory, imagine it. Put it in the form of a diagram, it becomes very, very easy. Okay. Question number 1 for you guys. 1.5 minutes to solve. Start. It is all about visualizing and looking at it. There is nothing to remember, no learning, no nothing. 1.5 minutes, I want answers. Can you see the screen? Can all of you see the question?
Yes, sir, we can see the screen.
Oh, chalo, 1.5 minutes. Okay, who has the answer? There's nothing to solve, it's just about visualizing it and looking at the diagram thoroughly.
Oh my.
Anyone who has an answer?
Sir, can you just give me 30 seconds?
Yeah, okay. Priscilla, think again. Priscilla, go through it again. You're close, go through it again. See what you're missing.
Is it 6?
Who's come up with 6? Bhavya? You can type in your answers now because we've started discussing. Yeah, please type in your answers. 6 is the right answer. Crazy.
Sir, can I tell how?
Yes, yeah, obviously. Come on. Go ahead. That's Bhavya, right?
Yes, sir. Sir, angle RDS is parallel to AC.
They're not angles, they're lines. We do not have angles, lines.
Sorry, they're lines, yeah.
RS is the line.
Oh, yeah. So, line RS is parallel to AC and AC is parallel to PQ and RS is parallel to PQ and then TU is parallel to DB. And then
DB.
Yeah, and then AB is parallel to DC and DA is parallel to BC.
Beautiful, beautiful. Everyone agree with Bhavya? Bhavya, was it you who gave the answer, right?
Yes, sir.
Yeah, Priscilla, I figured it out. I know what you missed, so it's okay. That's the reason I just asked you to check again. Cool. So whatever is being said, who did not get the answer? Let me just explain it to you. It is simple, guys. Look at the diagram and understand. RS is parallel to AC. Just on the previous slide, we said that there are two parallel lines. And if there's a third parallel line, what does it become? AB becomes parallel to CD. AB becomes parallel to EF. Correct? All of them are parallel to each other. Similarly, RS is parallel to AC. AC is parallel to PQ. And RS is parallel to PQ as well. All of you agree with this? We are talking about this, this and this. Are we clear? These three lines are taken care of. Now what's next? We look at DB and we look at TU. DB is parallel to TU, guys. Just by observation, sheer looking at the diagram. What is left? AB and DC are parallel. AB is parallel to
And even DA are parallel to CB.
Perfect. So AD is parallel to BC. How many? 1, 2, 3, 4, 5, 6. The answer is 6 pairs of parallel lines in the given figure. Are we clear with this? No doubts?
Yes, sir. No doubts.
This is a good question. 2 to 2.5 minutes, guys. Chat.
So I didn't understand this question.
Okay. You see X, that is angle CEF. We have to find the value of X in angle. What is the degree? He is given that CD and EF are parallel to each other and AB and CD are also parallel to each other. Remember, there's a hint that I'm giving you. When we're talking about parallel lines, irrespective of how much you extend them, they are parallel. Another hint is look at the transversal. Bhavya, check again. I think you're making a calculation error and not a conceptual one. Go again. You have another minute. Any answers yet? Russell and Bhavya? Vatsala, Arna? I don't know what to do.
Sir, I don't know what to do and I didn't even understand.
Okay, okay. There's some good questions. They're very conceptual. You will be like, oh, when I solve this. You know the funda. Let's see how you can apply it now. Okay, chalo. You guys have understood the question. We have to find the measure of this angle, and he has told us that CD and EF are parallel. That means CD and EF, these two lines are parallel, and AB and CD are also parallel. That means, how do I modify this diagram? Remember, parallel lines, irrespective of how much I extend, they remain parallel. So I am extending. Now they look like two parallel lines. If I extend this, does it look like a transversal?
Yes, sir.
Yes, sir.
If I extend this, does it look like a transversal again?
Yes, sir.
Now let's look at what all we can do. Angle ABC is 65 degrees.
Yes, sir.
Alternate interior angles are equal.
Yes, sir.
Right? So which angle would be 65 degrees if angle ABC is 65?
BCD.
ABC equal to angle BCD. Everyone agree with this?
Yes, sir.
Yes, sir.
That means this entire angle is 65 degrees.
Yes, sir.
What would be angle ECD? Only this choto angle. How do I get that?
Sir, 65 minus 30.
Everyone agree with that? Arna, do you agree with 65 minus 30?
Yes, sir.
Okay. So what is 65 minus 30? 35 degrees. You guys agree?
Sir.
Correct?
Yes, sir.
Now.
So the answer is 145 degrees.
Yes, exactly. So if this is 35, what would this angle be?
35.
Why?
So because
Because they are corresponding angles, right?
Yes, sir.
Therefore, 35 and 35 are the same. Now, we have this straight line. What is the measure of angle at a straight line? 180 degrees. That means if this is 35, what should angle X be?
145.
180 minus 35.
You guys agree? And does X already look like an obtuse angle?
Yes. Yes.
Does CEF look like an obtuse angle? This is E. You're
Yes.
getting me? Exactly. So the entire thing is forming 180 degrees. Perfect. You guys now understand. You do not have to stick to the diagram because we're talking about parallel lines, because we're talking about transversals. We can extend it, right? We can extend all transversals. We can extend all parallels because they will not change. Irrespective of how much you extend, they are going to remain parallel. Everyone is clear with 145? Obtuse because it's lying between 90 and 180. 145 is the answer. Everyone's clear? Yes, Bhavya. Sir, so next. Okay, type. Okay. Is everyone clear? Type in a yes or a no. Now you understand. The question was simple. I don't know why you told me that you couldn't understand. Try to change, try to do some kind of a modification anywhere that is required, where it does not alter the entire diagram. It was so simple. It was a good question, but the concept was very basic.
I didn't think about extending it.
Yeah. So